When you encounter a question like this, where you have x in terms of some other parameter that's not y, in this case theta, and y in terms of that same parameter, in order to find dy by dx, to differentiate, you need something called parametric differentiation, which is a variation on the chain rule, where we find dy by dx by dividing dy by d theta by dx by d theta. So we need to differentiate x with respect to our parameter theta and y with respect to our parameter theta, and then divide the two. So this is what we're going to be using for our parametric differentiation. So let's start by finding dx by d theta. So if you differentiate 1 minus 2 cosine theta with respect to theta, you'll have dx by d theta. The derivative of 1 is 0, and the derivative of cosine is negative sine. So you end up with negative 2 sine theta. And if we do the same for y by differentiating dy by d theta, the derivative of a sine is cosine. So it's simply 3 cosine theta. And now, to find dy by dx, we divide dy by d theta divided by dx by d theta. So dy by dx equals, I'm going to divide this by this. So I'm going to put this in the numerator and this in the denominator. So it's 3 cosine theta over negative 2 sine theta. So that's dy by dx. You could rewrite that as negative 3 over 2 cotan theta if you wanted, but that's good enough for the purposes of this question. It says find dy by dx in terms of theta, and we've done that there. So that's part A complete. Now, part B says find the coordinates of the points on the curve where the tangent is either parallel to the x-axis, that means horizontal, or parallel to the y-axis, that means vertical. So we need to figure out what that means in terms of dy by dx. So if something is parallel to the x-axis, that's the x-axis, something being parallel to the x-axis, the tangent is parallel to the x-axis, it means it's going to be either here or there. All right, these are the two tangents that appear to be horizontal. And at these points, the gradient, or dy by dx, is going to be 0. So dy by dx for any horizontal line is 0. So let me write that out. Dy by dx equals 0 for horizontal lines. Okay, so they want the coordinates of the points, so they want x and y for the points where dy by dx equals 0. That's similar to when they would ask for the stationary points. So I'm going to write that out. I'm going to say dy by dx equals 0 if it's parallel to the x-axis. So the expression we found, 3 cosine theta over negative 2 sine theta, equals 0. So that's what we're trying to solve. Now, whenever you have a fraction equals 0, it's enough to say that the numerator is equal to 0, because we can multiply both sides by the denominator and it would disappear. So it's enough to say that 3 cosine theta equals 0. So cosine theta has to be equal to 0, and therefore theta equals inverse cosine of 0. Now, when is cosine 0, or what's the inverse cosine of 0? We're going to say, you can use your calculator for this, but make sure your calculator is in radians, right? Whenever you have parametric equations involving theta, these polar plots are always in radians, and they've told us that theta is between 0 and 2 pi. So the inverse cosine of 0 is pi over 2. So that's your first solution. Your second solution will be 2 pi minus pi over 2, because you've got a cosine. All right, so these are your two solutions. But they're not asking for the values of theta. The question asks for the coordinates of the point. Let me show you. The question says, find the coordinates of the points. So that means they're looking for x and y. Now, to find x and y, you're going to need the expression for x and y. So we're going to have to plug in the two values of theta into our expressions for x and y. So we're going to have to do that twice. So for x1, we'd say x1 equals 1 minus 2 cosine theta 1. But I guess we know the cosine is 0 because that's where it came from. So it's going to be equal to 1. And x2 is 1 minus 2 cosine theta 2. And it's the same. y1 equals 3 sine theta. So it'll be 3 sine pi over 2. That's going to be 3. And y2 equals 3 sine 7 pi over 2. And that will be negative 3. Yes, I forgot to mention that this is actually here 7 pi over 2. So now we've found the coordinates x1, y1, x2, y2. We can write it out properly and say the points are 1, 3 and 1, negative 3. So x1 with y1 and x2 with y2. So these are the actual answers. All right, so it isn't enough to find theta. We need to actually substitute theta into here in order to find the values of x1, x2, y1, y2, because the question is asking for the coordinates. So that was BI, where we're looking for parallel to the y-axis, or to the x-axis. Now, if we're going to look at the next part, it says the tangent is parallel to the y-axis. That means rather than having horizontal tangents, we're looking at vertical tangents. So we're now looking at tangents that do this. They're vertical. So the gradient of a vertical line isn't 0. The gradient of a vertical line, dy by dx, for a vertical line is undefined. So let's say it approaches infinity. It's undefined for vertical lines. So we can say, just like we said here, dy by dx equals 0, I'm going to say dy by dx is undefined, parallel to the y-axis. So remember, dy by dx has an expression that they asked us to find. So it's this expression here. So 3 cosine theta over minus 2 sine theta. So that is going to be undefined. And when you have a fraction, for it to be undefined, then the denominator has to be 0. So it's something divided by 0 that makes it undefined. So we're going to say minus 2 sine theta is equal to 0. And then we'll solve to find theta. So negative 2 sine theta has to be equal to 0. So sine theta is equal to 0. So theta 1 is sine inverse of 0, which is 0. And theta 2 is pi minus 0, which is pi. So these are our two solutions for theta, 0 and pi. And as before, that's not enough. We need to substitute that in our two equations for x and y. So let me take this and bring that down here. So I'm going to substitute the values of theta 1 and theta 2 to find x1 and x2. So x1 is 1 minus 2 cosine 0, which looks like it's going to be negative 1, and x2 is 1 minus 2 cosine pi, which looks like it's cosine pi is minus 1. Hang on, so did I get this right? 1 minus 2 times 1 is negative 1, correct? 1 minus 2 times minus 1 is 3. So that's x1 and x2. And then y1 is simply 3 sine 0, which is 0. And y2 is 3 sine pi, and that's also 0. Right, so we know the coordinates of the y points, and that sort of makes sense. So we're looking for the points where the tangents are vertical. So these points have y coordinate 0 and x coordinates minus 1 and 3. Whereas what we found before were these 2 points where the x coordinate was 1 and the y coordinate was 3 and negative 3. So I can now say that my points are x1, y1, so minus 1, 0, and x2, y2, 3, 0. And that really would be your final answer for part B2. So it isn't enough to find theta. We need to substitute theta to find the x's and y's, and then you write them in this way. So that would be your final answer. So remember, whenever they ask for something, for a tangent that's horizontal or parallel to the x-axis, then you need to remember that dy by dx is 0. And if they ask for tangents which are vertical or parallel to the y-axis, then dy by dx is undefined, or it's equal to infinity. It can't be equal to infinity, but let's just say it approaches infinity because the denominator is 0. So it's undefined because the denominator is 0. Remember, always have your calculator in radians whenever you're doing this kind of question. So whether it's integration, differentiation, or polar parametric differentiation, you need to have your calculator in radians. Otherwise, you'll probably get the wrong answer. You might be lucky to get this one right, but everything else would be wrong. So I hope you found that helpful.